All right, so today we're going to do tests for parallelograms, right? This one I will tell you, when you end up taking a chapter test over this stuff, this one tends to get people in trouble. All right, so it's like an if-then, right? If any one of these things is true, then you know it's a parallelogram, yeah? And these are all basically the characteristics. If AB is parallel to DC, and not just one, but the other ones are parallel too, right? Both parts have to be parallel, then it's a parallelogram, yeah? If both pairs of opposite sides are equal, so if this is equal to this and this is equal to this, then it's a parallelogram, yeah? If the opposite angles are congruent, all right? So if this angle is congruent to this angle and this angle is congruent to that angle, then it's a parallelogram. The not so obvious one, the one that I actually use more than, because I usually hide it with this, if the diagonals bisect each other, yeah, so this would have to be equal to that and that would have to be equal to that, then it's also a parallelogram, yeah? If one pair, now this is the one some people don't get. If one pair, so let's just say this pair, yes, opposite sides. If they're parallel and they're congruent, yeah, then they have to be, then it has to be a parallelogram. All right, so that's the 1, 2, 3, 4. There's 5 ways you can prove something's a parallelogram. Yeah, all right, so pretty simple here. So find x and y so that it's a parallelogram. Yeah, well, what would have to be true if it was a parallelogram? If it's a parallelogram, wouldn't it have to, if I could prove that the opposite sides are equal, right? This side's equal to that and this side's equal to that, then it would be a parallelogram, right? So just figure out where 6x plus 13 is equal to what? 15, right? So we get what? 6x equals, oh, is it 3? No wonder, okay, 3. So minus 3 is 12, right? And x is 2. So if x is 2, that would prove that FG was equal to JH, right? It's not enough. What else has to be true? FJ has to be equal to GH. So we get 4x minus 2y equals 2. Since we already solved for x, we can just say 8 minus 2y equals 2. Minus 8 minus 8, negative 2y equals negative 6. So y is 3. So if y was 3 and x was 2, it would be a parallelogram. Easy? All right. Number 1, what could I prove? What would prove that they are parallelograms? If the sides were equal, right? So this is basically the same problem again, right? 2x minus 2 is equal to 12. So that would be what? Sorry, I zoomed in here. So that'd be what? X equals 2x equals 14. So if x was 7, that would prove the top and bottom were equal. And if 2y equaled 8, so if y was 4, that would prove they were equal. Yeah? All right, 2. What could I prove here? I could prove the opposite angles were equal, right? All right. So if 11x was equal to 55, right? What would that prove? If x was 5, that would mean both of these angles were 55. Can you picture that? Now, you also know these have to be supplementary because it's, we don't know it's a parallelogram yet. We're proving it. So if 5y equaled what here? 120. Okay, so that's not so intuitive, but if that was 125, right? And you can get that because you know those are both 55. You know these have to be equal. So that would have to be 125, 125, right? All right, so if 5y equaled 125, if y equaled 25, then it would be a parallelogram. Easy? All right, I'm not going to do 3 because 3 is basically 2 again. Let's look at 4. Yeah? All right, if 18 equals 6y, what would that prove? What would that prove? These sides are equal, right? Congruent. But that's not enough, right? What else do I have to prove? Something. I can't prove the other side because I know nothing about the other sides.
You have to prove the sides are parallel by
Okay, so if I could prove that the side, and that's where we're going with this, if I could prove that these sides were parallel, if they're equal and parallel, that is enough for what? Opposite sides are equal and parallel, that's enough to prove that they're a parallelogram, right? The number one mistake people make is already assuming it's a parallelogram. And so they start saying characteristics of parallelograms to do it, but you're proving that it's a parallelogram, so you don't know the things are true. Yeah? We don't have to go that far with it, because if I can prove that this angle is equal to this angle, right? Wouldn't that then be a transversal? If this angle is equal to this angle, then that would prove that that transversal opposite interior proves that they'll be equal. So if I just make those equal, I'm good, right? If 45 equaled 9x, we're not going through the proof of this, but if x was 5, that would mean those angles were 45, which is alt interior would prove the lines are parallel. Yeah? All right, next one. Which one are we using here? Not so intuitive, but look, if this was if this was equal to this, if these two were equal, then that would prove that these angles were parallel. These sides were parallel, right? And if this was equal to this, that would prove that these sides were parallel. So let's just go through it. If 2x equals 30, if x was 15, that would prove the left side and the right side are parallel. You get the logic of that? Because alt interior, same process. And then if x plus y equaled 24, so if 15 plus y equaled 24, or if y equaled 9, that would be enough, yeah? All right. 6 is basically the same thing. I don't even think we need to worry about it, yeah? All right, let's go to 3. Okay, now we're going to prove, there's two main ways to prove that quadrilaterals are parallelograms, using the slopes and using the distances. Or a slope and a distance could work. Yeah, that's usually what we do. There's some other ways you can do it, because if you can prove any one of these, you can do it. Yeah? All right, so what would the slope version be? What would you prove? If I could prove that this slope is parallel to this slope, and this slope is parallel to that slope, that's enough to prove it, right? So we just go through it. So we're going to find the slope of AD and BC. We're going to find the slope of AB and DC, right? So we're going to find the slopes of all these. I'm not going to go through all the work for this. Give me one. Figure out which slopes you know. Give me one of them that you figure out. 3? Well, 3. It is not undefined. And BC, can we verify that's 3? It's up 3, right 1, right? So that's 3. Good. Okay, so those are parallel. Good. Someone give me AB and DC, please. It's down 1, right 5, right? So negative 1/5. And DC is down 1, right 5 also? Yep, negative 1/5. All right, see what I'm doing there? So that's enough to prove that they're parallel, right? Okay, now what could I do with distance? I could prove this distance is equal. I could prove this distance is equal to this distance, and this distance is equal to this distance. And if that's enough to prove that that works. I could also prove that this is parallel and this is parallel, and they're equal. If opposite sides are parallel and equal, I could also use that method. So you can use a little part of both, right? All right, so we've got to find the distances. What's the length of AB, DC, AD, and BC, right? All right, the square root of, I don't even care what it is, I just care if they're equal, yeah? It's what? How far on the x? 1 squared plus, how far on the y's? Oh, I'm doing AB, I'm sorry. Oh, hold on, I gotta fix that. I was doing AD first. AB, how far on the x?
5.
So that's 5 squared plus 1 squared, which is root 26. You don't have to simplify it, even if you could simplify it. Just leave it. root 26. Look at DC. How far on the x's? 5. So that's 5 squared plus 1 squared, which is root 26, yeah? All right, AD. That's going to be 1 squared plus, I think it's 3 squared, right? So that's root 10. And just do the same with that one. That's 1 squared plus 3 squared, which is root 10. There's some other ways you can do it that they may do on your homework tonight. Look here. If you prove that AD was parallel and equal, AD and BC were parallel and equal, that'd be enough. You could also prove that the angles bisect, that those bisect each other. So what you could do is you could find the midpoint of DB and find the midpoint of AC and see if it's the same point. If it is, then they're bisecting each other. So that's another way to do it, yeah? All right. Let's do C and D, yeah? Because C and D are those versions. We already did A and B type, right? So let's do C and D. All right. So we've got to make a little sketch of this real quick, right? So negative 2, 4, 1, 2, 3, 4. That's S. My gosh, I cannot write. S. Negative 1, negative 1. That's T. 1, 2, 3, 4. 1, 2, 3, 4. That's U. And 2, 1. That is V, right? My gosh, it does not look like it would be a parallelogram, but okay. It's looking like this, right? Well, I guess it does. Yeah, that doesn't look too bad. Yeah? All right, so how can we use the distance and the slope? So what would you do? So what I would do is I would find ST, the length and the slope. So I would find the length of ST and the slope of ST. And then I would find the length of VU and the slope of VU. Yeah? All right, the length of ST. So we're going from S to T. How far on the x's? I'm really just focusing on this, right? ST and VU. I'm looking at those two, right? Like that. So how far between the x's? So that's 1 squared plus. How far between the y's? 5. So that's root 26. How far between, let's do the other, well, let's just do the slope. So what is that? 4, it'll be 5 over, isn't it 5 over negative, I think it's negative 5, right? So negative 5, slope of negative 5. You got to show me your work there for that on your homework. I'm just doing it a little bit faster. Negative 5, yeah? Do you know when you do your homework tonight, show me how you got that, right? So what did we do? We did what did we do? 4 plus 1 over negative 2 plus 1, right? Which is negative 5, right? All right. How long is VU? The square root of, how far between the x's? 1 squared and 5 squared. So we're good. So that's root 26. Good. And then let's do the slope. Let's see. How far between the y's? Negative 4 minus 1 over 3 minus 2. So negative 5 over 1, which is negative 5. So they're parallel and they're congruent. Is that hard? Yeah. Basic algebra, yeah? And geometry. All right. What about the midpoints? What could I do? I'm gonna do the a quick little sketch of it. So let's see. 1, 2, 3, 1, 2, 3. So like up here, that's F. 1, 2, that's G. Negative 3, 1. All right, and negative 1, 4. Good Lord, that doesn't look. Negative 1, 4. Why is that? What am I looking at? Negative 3, 1. How can that be my? Okay, that I had to have drawn that poorly. I'm gonna have to do this again because something looks way off there. All right, 1, 2, 3, 1, 2, 3. All right, point there. That's F, right? 1, 2. That is G. 1, 2, 3, 1. That is h. Negative 1, 4. It's not looking pretty good to me, but maybe it's proving that they're not. Who knows? We'll see. That is not looking good to me. All right, so what are we looking for? What was this one up here? What's this one? Negative 1, 4, that's I, right? I guess this is G down here. That's G. Okay. So I'm gonna find the midpoint of IJ or IG, and I'm gonna find the midpoint of HF, right? And remember how you find midpoint. Average of the x's, average of the y's, right? Okay, I is at what? Average of the x's, negative 1 plus G is 1 over 2. See what I'm doing? I'm focusing on IG right now. So this one and this one, right? And then what do we got? 2 plus 4 over 2? Okay, so what's that point? So the midpoint of that is at 0, 3. So what I'm trying to see is if the other midpoint is at 0, 3. Yeah? All right. So now I'm doing H and F. So 3 plus negative 3 over, over 2. That's 0. That's good, right? So that's 0. And the 3 plus 1 over 2, which is 1. See the problem? See the problem if you're bad at math? 2. All right, what does that prove? Not a parallelogram, right? This one is a yes, yes, right? All right, then I'll do example 5. I've seen these, math team, I've seen these on math counts tests. I am going to draw this one on a separate sheet, because if I try to draw it there, I am going to run out of room pretty quickly. Right. All right. All right, so give me the, I'm going to make a quick little sketch of this, right? Give me the points. Negative 2, negative 1?
Yes.
And what's that point?
That's R. 2, 1.
2, 1.
Which is S. And then 0, negative 3, which is T.
All right.
Yeah.
All right, so I got those points here, right? I got these points. Now the first question is, well, how many parallelograms could I draw using those points? You see what I'm saying? All right. So there's a lot of ways to do this. We can just do this the obvious way. So what we're going to do is, I'm going to keep changing my colors here. So, all right. So let's take this one right here, right? See this? See what we're doing here? That parallelogram. You see it? All right. So the question is, where is this at, right? Well, if you think it through, it's going to be the same slope, right? The distance up and over is going to be the same distance up and over. Yeah? So how much up? Well, is it 4? All right, so up 4. Is it? And am I wrong on this? I think because if that's 2, if that's negative up 2. Okay, that made more sense to me. Up 2, right 1, right? So up 2. Stop. Let's slow down here and stop giving me 26 answers that are wrong. Let's just take your time and give me one correct answer so we won't confuse the entire world, okay? How far are we moving up?
2.
Up 2. Right, how many?
4. 2, negative.
So up 2, right 1, 2, 3, 4. So it's a little bit over, right? So I'm looking at, see what I'm looking at here? That's one of the points, yeah? Yeah? All right, I'll give you the little shortcut. You can start playing with this for a while, but you see this triangle here? The easiest way to do it is there's a point over here that works. there's going to be a point over here that works somewhere. Yeah? Somewhere over here somewhere. And there's going to be a point over here that works. Make sense? And you can see them. And they're pretty easy to find. So we got that one, right? We just found this one, right? You see it? Like that? So that's one of the points. What is that point? Then we move it up 2, right 4. Up 2. So that's negative 1, 3, I think? Oh, 3, negative 1? I keep going backwards because I'm doing slope. 3, negative 1? We are going up 1, 2. 1, 2, 3. Okay. 4, negative 1? All right. All right, let's do the point up here. There's a point up here somewhere, right? Somewhere up here there's a point. All right. Well, how do I find it? Well, what you focus in on is, you see this line right here? That line's going to be like this up here. See it? All right, so what am I doing? Well, this slope, right? This slope right here would be that slope right there. So up 1, 2, 3, 4, right 2, huh? So up 1, 2, 3, 4, right 2. I think I'm here, aren't I? That sounds reasonable? Yeah. Yeah. I'm going to change my color here. So, like this. See how it looks? When you find this last point, it'll be over here somewhere, and it starts looking like all you Link Legend of Zelda fans. It looks like a Triforce, yes? Yeah? All right. So let's do the last one. So now what are we looking at? There's a point over here, yes? Somewhere? All right. That's that point, right? So it'll be like this somehow, right? Actually, it's more like this over here somewhere, right? All right. Well, how do I find it? Well, the distance you go down and left is the distance you'll go down and left. So down how far? Down 4. Left how many? 2. So down 4. 1, 2, 3, 4. Left 2 is about here, it looks like. Yeah? So let's see. I'm going to do this one in purple. Like this. Actually, why is that so far off? Yeah, I should have. Okay, so what I did is I moved it from here and over, and I should have moved it from here and over. So you can see the mistakes you can make. Yeah? All right, so what did I say? Down what? 4. Down 4. 1, 2, 3, 4, and then left 2. That's about here. And you can see it, right? See that one right there? Yeah? All right. So there's my points, right? See, we just labeled those points, and that would be your 3 points that can be at. I think you have one like that. All right? All right. Graph it carefully. All right. That's how you do these. Not that bad.